Well, hello, Canadian high school students. This is Mr. Hood, and I'm going to be videoing a redox titration video, and there's going to be 3 steps. Number 1, make the KMNO4 at 0.02 molar. Number 2, given that molarity of permanganate, we are going to titrate it with a known primary standard, FAS, ferrous ammonium sulfate, or Moore's salt. It's known 3 ways. And we'll get an exact concentration of that 0.02 molar KMNO4. It may be 0.01973 or 0.02013. Whatever it is, we're going to try to get to 4 significant figures using the buret. In a moment, we'll see that. So number 1, make the KMNO4. Number 2, standardize the KMNO4. And number 3, we're going to analyze an unknown salt of iron 2. So one of the most standard AP redox titration is permanganate iron 2, and I've done it for 15 years. We'll do it again. A moment ago, I had an intro. Here's the very nice balance donated by Mr. Northcott and the dad of Richie and Molly Northcott. Very nice balance. It measures to the nearest milligram, so we'll get very good accuracy. I'm going to make this potassium permanganate, which is 97% pure KMNO4. It's a very dark purple. And I've used this same Nalgene bottle for years, and see how it's turned kind of purple. When I was a kid, my grandma had something called monkey blood that would be an antiseptic. So it's kind of purplish. So in this titration, we will not have an acid-base indicator. The permanganate added, it turns this solution purple. So I'm gonna make 1 liter of that in a moment. I think it's like 3.16 grams is roughly 0.02 molar. So once I make that solution, I'm going to standardize it with this Moore's salt, ferrous ammonium sulfate. And the molar mass is on there, if you can see it clearly. It's 392.16 grams per mole. And there's the chemical. I'll have the chemical formula on the Word document so it's visible. And a long time ago, this was called Moore's salt. And this was an older version. There's my more recent Flynn, purchased 2015. And once I standardize that permanganate with this FAS, ferrous ammonium sulfate, I will take this unknown, and what I used to do is like, okay, students, this is just a compound of iron in it, but now you can see it's ferrous sulfate, and some of my better students will know that ferrous is a +2 ion. Oh, excuse me, spoiler alert, and ferric is +3, but this is going to be ferrous sulfate. Wait a second, where's the molar mass? So I'm going to leave that kind of hidden. They're going to find the percent iron in this compound, and then they're going to tell me the number of waters in the hydrated form of this ferrous sulfate. So that's kind of you can probably Google it and find it, but they have to mathematically prove it anyway. So they're going to prove how many waters are in this, how many waters per formula unit of FeSO4, ferrous sulfate. Okay, the titration will begin soon. So I'm going to make my 0.02 molar potassium permanganate. I'm using 97%. So you can see that if I make a small mistake making the solution, I'm going to try my very best to fill up exactly to the 1 liter line here. But even if I did make a mistake on this one, it doesn't matter because I'm going to standardize this multiple times. So I'm going to do it 2 or 3 times myself. My students, which I've got 4 lab groups this year, there's only 8 or 9 AP Chems this year, and we are very easy to social distance in this lab. So there'll be 2 people per table, and they'll be doing this lab in the next week or so. This is Saturday, October 10th, and it is Saturday night. That's how wonderful my life is. I'm videoing this lab on a Saturday night. Ooh, hot day in Canadian Texas here. And Texas Tech just lost again to Iowa State. That's great. I think OU won. They beat UT at the Red River Shootout. So that's why I'm trying to boost my spirits here doing a lab on Saturday night in Canadian Texas. So I'm going to make, when you make a solution, if you dilute a solution of like hydrochloric acid, do as you oughta, pour acid into water. So when I make the solution, I'm going to half fill it with water, then I'm going to add the very dark purple potassium permanganate, and you will tell, even at a low molarity, 0.02, which is like basically 2 centimolar, very small concentration, it's really deep purple. So that's why this bottle is all messed up from years of use. So I have a dish. I'm gonna get a weighing dish, and I'm gonna get about 3.16 grams. I don't have to be exact because I'm going to standardize it, but I'll try to get as close as I can. You'll see it's a very dark purple chemical here. There it is. See, it's dark purple. It's hard to put this up to an iPad to see the video, but you'll see it in a moment. So I'm going to tare my weighing dish, and I'll carefully add 3.16 grams. That little scoop was about 0.3 grams, so I'll do a few more scoops and fast forward this video as it happens. Let's see if that's about 3.16 grams. That's a little too much. Now, is Mr. Hood going to pour this back in the bottle? No, students, don't do that. We're going to put it over here and I'm going to waste some. That's okay, because this bottle is like 30 years old and I only use 3 grams a year, and there's like 500 grams in here. So I will be dead before this is used up. That's 4.2. And I'll just waste this much because I waste a lot of stuff. That's a little bit less, 2.976. Let me just sprinkle a little bit more. And if I were Salt Bae, I'd just do this all over it, but I'm not going to do that because it's permanganate. 3, oh my good gravy. What does that read? 3.160 or 161. Great job, Mr. Hood. So I'll have to see what molarity that will be in a moment. So I take this solution as I make it. I'll write down powder funnels. Here's my solution. And I want to get every millimole of this permanganate into this solution. So you'll see it turn really deep purple. Oh, look at that, and that purple on the weighing dish. I'm trying to get every millimole, that purple. There's one little flake of permanganate on the side of here, so I'm going to get that in there. Now, I got some purple on my finger, so it's going to oxidize, and I'll have kind of red-looking fingers. So that's a little bit of source of error. I'm not going to get every millimole of permanganate into there. Okay, this is just going to be cool because this is my excess permanganate. Do you see it in there? I'm just going to pour a little water in it. And look how deep purple that. Look how deep purple that is. So it's really deep purple. And I'm going to throw this away in a moment. So you saw how deep purple that turned, and that's only 0.02 molar. And I'll keep rinsing down in here until it gets to the neck. And instead of, then I'll start mixing it right then. I can find the rubber stopper. Here it is. Have to edit this video. I'll mix it. At the very bottom, you'll see a couple of flakes. As you mix a permanganate solution, you'll see a couple of flakes that don't get totally dissolved. So I'll shaken, not stirred. That's why you don't fill it up totally and then try to dissolve it, because then you'll have to go bloop, 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 bloop many times, and you'll see little flakes of permanganate up here. I'll have to mix it very thoroughly. And that's why I will not keep this in this glass volumetric flask. I'll put it in this old nasty plastic container. That's the only use for it, is permanganate every year. I'll edit this video so you don't see me doing this all the time. And a lot of mistakes students make when they make molar solutions is they pour it too quickly. I use regular distilled water from the store, and I've not had any problems with it, even when I do some precipitates with lead compounds. Like right there, it's about to fill up. And I don't want to... Right here is where they'd say whoops, when you get to the neck, it goes really fast. So I'm going to do one more flip. How my flask got flipped, turned upside down. Fresh Prince. And I will use my wash bottle, wash down all the permanganate, and then I will use another wash bottle that's not so empty, because my students didn't refill it, neither did I. There it is. Now it's full. That was magic. Okay, you cannot see this. Now, usually when I look at a buret or a meniscus, for clear liquids, I'd use the bottom. Sometimes I'm going to use the top. But for this one, I'm going to use the bottom. It's going to be dark purple, hard to see. But even if I mess that up, who cares? Because I'm going to standardize it anyway multiple times. Okay, made the solution. Next, I'll calculate the molarity, and I'll use it to titrate with FAS, primary standard. Okay, this is the permanganate. I'm pouring carefully into this buret, and I will spill it. I'll probably use a beaker later. Oh, look at that. Oh yeah, baby, I'm doing it right. It's pouring. It's very deep purple. So I will be very careful when I get rid of the solution. I will not leave this permanganate overnight in this glass buret, because it may stain it or something, I'm afraid. And one thing, usually when I read the meniscus for a clear solution, I read the bottom of the meniscus. Sometimes I cannot help, but I can't read the bottom. If you can come in closer, you can see that's very dark purple, and you can hardly see the bottom of the meniscus. And I'll take a clear picture better in a moment. But I'm gonna let the permanganate go through the tip. There we have no more water, no more air bubbles, excuse me. So I'm going to read to the nearest tenth and estimate to the 100th of a milliliter on this buret in a moment. Okay, this is trial one of a Redox titration, titrating KMNO4 with this 1.113 grams of FAS. Now for this Redox to work, we have to have acid. So I've got way more acid than I need. So I've got 15 milliliters of 1 molar H2SO4, and you can mathematically prove you have excess acid. I'll add that in there later. I'm just going to put a little bit of water in there because I titrate with water, and it's going to dissolve the FAS. And I'll pour the sulfuric acid so that the redox titration works in a 1:5:8 ratio. If you didn't know, the reason grad cylinders have a little hexagon shape on the end of them, some of you know this, some of you may not know. Let me rinse the sulfuric acid out of there. And if I leave it up here, whoops, I could tip it over, but if you lay it down, it will not roll off, so it's safe. If you didn't know that, that's something you learned just now. Most of my students should know that. Let's see if they do. It's going to be about 25 milliliters of this. So I'm just going to shoot her down. Now the correct procedure for a titration is if I'm right-handed, I'm going to use my right hand to hold this and swirl. I'll use my left hand to control. Can you see that? Beautiful camera lady. And so I don't accidentally flip it out. I put the buret tip right down there so it's going to hit. Here we go. Titration, titration. 4 milliliters, 5 milliliters, 6 milliliters. I think 1 gram of FAS is about 25 milliliters, so this may be 25 to 30, and I'll find out very soon. $11 milliliters, 12 milliliters, and I'll edit this video so you don't see all this. I'll shoot down to the bottom, and of course there's a fly flying around when we video, of course. That's when flies come by. See the the dark purple permanganate is staying in there longer as it reacts. So it's oxidizing the iron 2 to iron 3, and when all the iron 2 is done oxidizing, the last drop of permanganate will turn this solution kind of a light pink, kind of like the phenolphthalein color with the acid-base titration. When there's one more drop of sodium hydroxide, the phenolphthalein turned pink. So permanganate is not an acid-base indicator, but this pink color in the solution will indicate 1 drop of excess permanganate. And there's my 1 drop. 1, 2, 3, 4. And I'll shoot it down until we get closer. We're at 19 milliliters. And it's really kind of gross, but almost urine colored, like Gatorade, like orange drink colored. It's getting close. 2, 3, 4, 5. See how that pink is staying longer? 7. It's about 29 point something milliliters. We're getting close. Right there. That's it. That's it. I caught 1 drop. Woo! Now I'm going to read that volume. That is why they pay me the big bucks. Right there. So, can you see there it goes. Between 29 and 30 milliliters, okay? And then we're going to stop this video and take a picture. And I'll clean up the buret and go home at 8:46 on a Saturday night.